Hi, today we're going to do number 141, linked list cycle. So we're giving a linked list, as you can see here, 3, 2, 0, 4, -4. And then we can see here it loops back to 2, so it's a cycle. So we return true. And see them here. Here, there's only a single one. There's no cycle, so we return false. So how can we solve this problem? One way to keep track of unique values is to use a set. And we can do that by creating a new set and then iterating through the cycle. Inside that cycle, we can check if we have seen that value. If we have seen that value, we return true, marking it as a cycle. But if we don't see it, let me do else, we add it to the set. And then if we can loop through the entire cycle if we can loop through the entire linked list, we can know that it's not a cycle. So we just return false. So what's the time and space complexity of that? The time complexity, since we're looping through the entire list of the linked list, is going to be O of n, where n is the length of the linked list. And then the space complexity, since we're creating this set, and this set can go as long as this linked list, is also going to be O of n. So how else can we solve this problem? And the other way we can use is the 2 pointers with the fast and slow pointer. So we initialize both of these. We create 2 pointers from the start. And while the fast pointer is valid, we loop through it with the slow pointer moving one step at a time. While the fast pointer, let me not use while, and fast pointer moves 2 steps. And then if the fast pointer can reach a slow pointer, if there's an overlap, we know that there's a cycle. Otherwise, if we reach the end of the pointer of the loop and there's never a cross, we return false. So what's the time and space complexity of this? Well, looping through with 2 pointers, so that's going to still be O of n. And here, since we're just creating space for the pointers, it's constant. So the space complexity will be O of 1. So since the fast and slow pointer has a better space complexity, we should go with this way. But I will show you both ways. So first, with the fast and slow, we create the fast pointer, and then we create the slow pointer. And now we loop through while fast is not null. And since we're going 2 steps at a time, we need fast.next too. Now we jump them, so slow equals slow dot next, fast equals fast dot next dot next. And now here we checked if slow equals fast, we have a cycle, so we return true. So otherwise, if we make it through, we make it through outside of this loop, we know there's no cycle, so we return false. sorry, since we need both of these values to be truthy, we don't need the exclamation while these both are true. Great, so that's the two-pointer way. And now for the set way, so we create a set const scene equals new set, and now we loop through head, and now we need a current variable to loop through head. So while current is truthy, we loop through it. So we first check if it's in the set. So if scene dot has current, we return true that there's a cycle. Otherwise, we add it to the set. And now, if we make it through the iteration without returning true, we return false. All right, and I forgot to move the current upwards. Great, so those are two ways we can do this problem, trying to identify the cycle. One way is to keep a set. Generally, set is good for anything unique. So we loop through this. If something has been seen before, we return true, otherwise we return false. The other way is we create two pointers and loop through this using the fast pointer as validating that is true, and then move the slow by 1, move the fast pointer by 2. If it's equal to each other, we hit a cycle, so we return true. Otherwise, if we make it through the loop, we return false. Thank you.